Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 10th April 2023. The problem statement for today is maximum intersecting lines. This problem is based on sorting and mathematical operations. And this has been asked in Swiggy interview. Let's now open this problem to solve it. Let's go through and understand the given problem. Here it is said, n horizontal line segments are arranged on x-axis of a 2D plane. The start and the end point of each line segment is given in n into 2 matrix, and the matrix name is lines. Your task is to find the maximum number of intersections possible of any vertical line with given n line segments. Okay, so here we are provided with n cross 2 matrix that is called given, the name is given as lines, and it consists of several line segments which contains both starting and the end point, starting point and the end point of a line segment. Okay, so here we need to find the maximum number of intersection that is possible for any vertical line. If you draw any vertical line over x-axis, so that should have the maximum intersection point. That means that should cut the maximum line segments which has been given in the input array. Okay, so let's understand the given examples here. So first of all, it is said that n is equal to 4. That means 4 line segments are there, and lines array, it consists of the starting and the end point of each of those line segment. So first one is starting at 1, ending at 3, then 2, 3, 1, 2, and 4, 4. So here the output is 3. Output is 3. A vertical line at x is equal to 2 passes through 1, 3, 2, 3, and 1, 2. That is 3 of the given horizontal lines. Okay, so let's understand this one with in a better way with the example here, with this graphical example. So here I have taken that example only, whatever it was given here in the question of 1, 3, 2, 3, 1, 1, 1, 2, and 4, 4. So here the first line is going starting from 1, it is going up to 2. Okay, so that is the that was the third line. First line is starting at 1, ending at 3. So starting at 1, ending at 3. Second line starting at 2, ending at 3. So this is the second line, starting at 2, ending at 3. Third line starting at 1, ending at 2. Starting at 1, ending at 2. Fourth line is starting at 4 and ending at 4. So here, this is the fourth line. That means the starting and the end point is at the same place. Okay. So here if you see, if I try to draw a vertical line here, something like this, then we can see that these three lines are getting intersected. Okay. So we can say that for x is equal to 2, it is intersecting x is equal to 2, that is vertical line at x is equal to 2, it is intersecting three line segments. That is the maximum number. If you take any other point, then it will not intersect more than 3. So that is the result here. So here it is said that here what we have to do, we have to find the maximum number of intersections possible. So at x is equal to 2 only, we have got 3 intersections. So that is the maximum possible intersection. So we have to compute this only. Okay, I hope the example is clear. Let's go to the second example. Here it is said that n is equal to 3 and lines array contains 1, 3, 5, 6 and 3, 4. Here the output is 2. The vertical line at x is equal to 3 passes through 2 of the horizontal lines, which is the maximum possible. Okay, so this one, when you draw a line, vertical line at x is equal to 3, so it will pass through 1, 3 and 3, 4. It will not cross any point of 5 and 6 because that is completely separate. That's why we have got the output 2, because it is intersecting 2 lines. Okay, so to solve this problem, the logic we will use is based on the fact that the maximum number of intersections of any vertical line with a given n line segment can be found by finding the maximum number of lines that overlap at any given point. Okay, the approach which we will use to solve this will be to use a tree map to store the endpoints of the line segments TreeMap is used because it maintains the order of keys in ascending order. Okay, so let's understand this one in a better way with this map here. Sorry, this one. So again, I have taken the same example. The first one, 1 3 2 3 1 2 and 4 4. Okay, so when it is taking this segment, this line segment in consideration, so what we are doing, we are marking the starting point as 1. So I'm incrementing the count of 1. That means whatever is the starting index, that will act as a key, and the count of such numbers, that will be as the value of the map. So here the 1 is there and it is having the first count here, so we are incrementing here, we are marking it as +1, but it is going starting at 1, it will go up to 3. So if you take the length of that line segment, it will be covering 1 2 and 3, but it will not cover 4. That's why what I have done here, incremented the value of this by 1 and marked it as -1. Okay, this is indicating that at 4 this line segment will be ended. That means it will be ended at 3 only, but yeah, but 3 will be part of it. 3 will be the part of it, but not 4. That's why I have marked 4 as -1. Similarly, when we go to the second one, so here since the starting point is here 2 not 1, so it is the one from the previous step. So starting point is 2, that's why incrementing the value of 1 here, because we have got another starting point, so just added one here, the value for that. And again this is also ending at 3, that's why again the same logic, we added 1 to it and decremented the value by 1 again. So here actually we are saying that at index 4 2 lines have ended. That means till 3 we will have the value as positive. Yeah, that means the value will be there. That means that will be valid. But as it reaches 4, that lines won't be existing there. That's why we are decrementing the value as -2. When we go to 1 and 2, so here we have got another starting point as 1 only. So we incremented the value of 1, so it became 2, and it is ending at 2. It is ending at 2 means it will be valid till 2 but not for 3. That's why we have added -1 for 3. When we go to the 4 one, that means the fourth line segment, so it is saying that we are starting at 1. That means whatever is the value in the previous step as -2, we added 1 to it, because for all starting point we are adding +1. So when we added +1 to it, it became -1. Okay, from -2 to -1, and it is ending at 5. That means it will be valid at 4 but not for 5. That's why we are marking it as -5. That means 5 as -1. Okay, so what we are doing, for each line segment we put the starting point in the tree map with the value of 1, representing the start of the line segment, and ending point +1 with the value of -1, representing the end of the line segment. This helps us to track the count of active lines at any point on the x-axis. Okay, so this will help us in tracking that how many lines are active at any given point. After processing all the line segments, what we do, we iterate over this map and keep track of the active lines. So whenever the new line segment starts, we increment the count of the active lines, and whenever the line segment ends, we decrement the count of active lines. At each point, we calculate the maximum number of active lines and update the intersections accordingly. So if you try to iterate this map here, so here when we are at first position, that means the first value of this map, so here we are seeing that number of active lines is 2. Okay, when we go to the next one, so it will add to this one, so number of maximum lines, it will now become 3. That means 2 plus 1, that will become 3. 2 plus 1 3. When we go to next one, so here the number of active lines, it will be 3 minus 1, that will be 2. When it will go to the next one, So here again minus 1 is there. So number of active lines will again decrement by 1. So it will be 1 only. And here at last it will be 0. Okay. So if you see this, if you try to analyze this one with this, I'll try to open this canvas here. So here at this point 1, how many lines were active? 2. So that only we have got here. Let me just minimize the size of it so that both the image is clearly visible. So here at x is equal to 1, we have got 2 active lines. At x is equal to 2, we have got 3 active lines, because 1, 2 and 3. When we move to 3, then how many active lines are there? 2. So see again here we have got 2 here. When we move to 4, then only one active line is there, that is this line starting at 4 and ending at 4. So that is valid for 4. So that is one active lines. That's why see here this we have got the active lines, one active lines. And when we move to 5, we do not have any active lines here. So that's why the number of active lines is 0. So here out of these 5, we have to see which is the maximum one. Maximum one is the 3. That's why that is the output. That means for x is equal to 2, we have got the maximum 3 lines that are active at that particular point. I hope this is this example is clear, and this explanation, this logic, everything is clear. Okay, so now with this logic only, let's try coding the solution for it. So I have already prepared a solution. I'll explain it again line by line. So let me copy it, this one. Yeah, so here this is the code for it. So I'll explain it what it is happening in this one. So to achieve whatever is asked in this problem, what we do was first create a tree map. First create a tree map with the name endpoints, which store the endpoints of all the given line segments as key and their frequency as the value. The keys of the tree map are automatically sorted in ascending order. So we can be sure that tree map will always store the endpoint in the correct order. Then what we do for each line segment in the input, what we do, we put the start point of the line segment as the key in the endpoint tree map and increment the value by 1. This one. So we are using the starting point, we are adding as the key, and we are incrementing the value by 1. Similarly, it puts the endpoint of the line segment plus 1 as the key here, the way we have done in the example before. That means whenever it was ending at 3, so we did 3 plus 1, and that we have added as minus 1. So that only is coded here. Okay, so similarly it puts the endpoint of the line segment plus 1 as the key in the endpoint tree map and decrements the value by 1. This is done to keep track of the number of lines that are active at any given point on the x-axis. By adding the endpoint of the line segment plus 1 to map with the value minus 1, we are effectively indicating that the line segment has ended and its contribution to the number of active lines should be removed from the count at this point. This process ensures that the endpoints tree map stores the number of line segments that cover each point on the x-axis. Okay, so once this point is done, then what we do? Then we initialize 2 variables, that is intersections and active lines, and both we initialize it to 0. The variable intersections store the maximum number of intersections at any vertical line with the given n line segment, while the variable active lines store the number of active lines at any given point. Finally, we are iterating over the endpoints tree map, this one. We iterate over the value of the endpoints tree map and updates the active lines and intersection variables accordingly. For each value in the tree map, the code adds its value to the active lines variables and update the intersection variables to be the maximum of its current value and the value of the active lines. Okay, so here this intersection, what does it take? It takes the maximum of the current value of the intersection and the maximum of the maximum of the active lines. So whatever is the maximum among these two, that is being updated as the value of intersections. Okay, so what exactly we do here in layman terms, we iterate over the values of the endpoint map, and we can use a running sum of the values to determine the number of active lines at the given point, and therefore the number of intersections that occur at any point. Okay, I hope this explanation is clear. So now let's try compiling this code. See, before compiling this code, whatever we are doing this last part, this is equivalent to whatever I have shown here. That means for each one, that means here it keeps on adding this one. First it will add 2 here. So for first iteration of this endpoint value, the value will be 2. So active count will be 2 here, active lines, and that only will be stored in the intersection for the first iteration, because the value of intersection is 0. Okay. Next point, when we move to next one, then it will add 1 to it, because active lines is equal to active lines plus count. So count here is 1, so it will add here. So now the count will become 3. Intersection in the previous step it hold 2, but now the current active lines is 3. So which is the maximum of it? Maximum of it is 3. That's why 3 will be updated in intersection. So for the so for the next iteration, what we do a minus operation here. That means the value of the count is -1. So once we do that, the number of active lines decreases by 1. So now intersection is holding value 3, but active lines is 2. So again the value won't be updated, it will still hold 3 only. Similarly, it goes on and tries to find the maximum of all the active lines, maximum active lines that are active at any given point. Okay, now let's try compiling this code. So here we can see we have got correct output. Let's try submitting this solution. This is the solution in Java. Here I have added comments against each line so that it becomes easy to understand for whoever sees the code. Okay, so here you can see here we have got our output. We have got correct output here. So this problem has been solved successfully using Java language. So now let's try solving this with C++ code. The logic will be still the same. Here even I have prepared the solution as well. Minimize this. So here the logic is completely same. Only the syntactical difference, whatever we get between C and C++ and Java, that itself is there. So here also we are creating a map. So first for this one, we are incrementing the value for starting of the array, and we are decrementing the value for the end of the line segment. Okay, then we again initialize these two variables and we keep on adding and we find the maximum. So let's try compiling this solution. So even the C++ code is giving correct output. If you try to submit this, then here also we can see it is giving correct solution for even for C++ code. That means it has passed all the test cases here. So talking about the time complexity of this code, it is in the order of big O of n log n, where n is the number of line segments. The reason for this is that the tree map used to store the endpoint has a log n time complexity for adding and retrieving elements. The loop that iterates the endpoint has the time complexity of big O of n. That's why it is making the overall time complexity as big O of n log n. Okay, so I hope this solution is clear to you. If you have any doubt related to this solution, then you can comment on this video. So I'll provide the link for this question and the code in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.